Hi, welcome back. In this video, I'm going to work out a couple of limit examples that we started in class. So the first one we're going to do is part B. There was a typo on the worksheet, so this is what it should have looked like. The limit as theta approaches 0 of cosine theta minus 1 over theta squared. So there's a little bit of a red herring in this problem. It looks like you're going to use the second limit formula, the one that says cosine theta minus 1 over theta approaches 0 as theta approaches 0, because it kind of looks like that, but that's not really what's going to happen, because notice that if you try to write it as the limit as theta approaches 0 of cosine theta minus 1 over theta times 1 over theta. The problem with that is that, yeah, this part is approaching 0, but that is approaching infinity. So this is another indeterminate form, something getting really tiny, approaching 0, multiplied by something getting really huge. We don't know what's going to happen. So this is an indeterminate form, and we will learn later how to deal with it. But for now, we can deal with this problem using the other formula, the other limit formula. So what we're going to do first is multiply the top and the bottom by the conjugate of the numerator. So we're multiplying by cosine theta plus 1. Then what we get is the limit as theta approaches 0 of, and the numerator is now going to be a difference of squares. It's going to be cosine squared theta minus 1. The denominator is just theta squared times cosine theta plus 1. Now, look at that numerator. We can use a trig identity there. Remember, cosine squared plus sine squared is equal to 1. So that Pythagorean identity tells us that cosine squared theta minus 1 is negative sine squared theta. So this is the limit as theta approaches 0 of negative sine squared theta over theta squared times cosine theta plus 1. Now we can pull that minus sign outside of the limit, and then we can rewrite sine squared theta over theta squared as sine theta over theta squared. And then we're still multiplying by 1 over cosine theta plus 1. So now we can see that sine theta over theta, that thing is approaching 1. And then over here, cosine theta plus 1, we can plug in 0 for theta. It's going to be cosine of 0 plus 1. So we get negative 1 squared times 1 over 1 plus 1, which is negative 1/2. All right, so there was a lot of algebra and some trigonometry, and we used the first limit formula. All right, let's look at another one. So this one says the limit as x approaches 0 of sine of 3x over 5x cubed minus 4x. So another red herring, that polynomial in the denominator is not really that bad. Notice in the denominator, both terms have an x, and we can factor that x out. So it's really x times 5x squared minus 4. And so I'm just going to rewrite everything as the limit as x approaches 0 of sine of 3x over x times 1 over 5x squared minus 4. So I just factored an x out of the polynomial. Now we see we have sine of 3x over x. Well, we'd like to multiply that denominator by 3. So we have sine 3x over 3x. But if we multiply the denominator by 3, we have to multiply the numerator by 3. So I'm just going to multiply everything by 3 over 3 and then rewrite it as the limit as x approaches 0 of sine of 3x over 3x times 3 over 5x squared minus 4. Now we can see that that thing is going to just go to 1. And then that fraction, we can just plug in 0. So we get 1 times 3 over 0 minus 4, which is negative 3/4. All right, let's do one more. So this last one looks kind of crazy complicated, and it's really quite simple if we just rewrite things in terms of sine and or cosine. So it says limit x approaches 0 of cosecant of x times sine of x. So let's rewrite that cosecant of x as 1 over sine of x using a reciprocal identity. And now we can see, we can rewrite that as the limit as x approaches 0 of sine of x over sine of x. Now notice that the numerator is sine of something, which I'll call theta, divided by something, the same something, sine of theta over theta. So, but we don't have a theta going to 0. Well, x is going to 0 means that sine of x has to be going to 0, right? If x is approaching 0, the sine of x is approaching 0. So theta is approaching 0 as x approaches 0. So I need to rewrite it in terms of theta. So that limit above is the same as the limit as theta approaches 0 of sine of theta over theta. So the whole thing is just approaching 1. All right, I hope this helps with the homework. Make sure you write out all your steps. You're using algebra, limit laws, trig identities, and the 2 limit formulas that we learned in 3.3. All right, I'll see you in another video.